Bismillahirrahmanirrahim. Assalamualaikum. So in this video, I'm going to show you the solution for induction motor tutorial for question number 7 and 8. Just for your reference, for the type of questions of induction motor that didn't give you the value of R1, R2, X1, X2 and Xm. So usually when you were not given those values R1, R2, X1, X2, Xm or Rc, you will not be able to calculate your I1 phase, I0 phase and I2 phase. Okay, so therefore there are different approach for this kind of question. Actually it's very simple, you just need to refer to the power flow diagram only. So let's get started with the question number 7. Okay, a three-phase it's 50 Hz 2-pole. Okay, it's a three-phase, the frequency is 50 Hz, number of pole is 2, it's a Y connected. So I line equal to I phase, V line equal to square root 3, angle of V phase. Angle of V phase you need to plus 30. Deliver 13.4 HP to a load at a speed of 2950 RPM. So there are two information there. One is 13.4 HP. Another one is 2950 RPM. So the motor deliver 30 HP to a load. So what power is this? So first, referring to the unit, is the unit for P max, and we know that for induction motor, P max is the P out, P in convert to P out. So P max is your P out. So this is your P out. Okay, but given in mechanical unit, that is HP. Okay, so you need to convert it into watt for you to do the calculation later. Okay. And then 2950 to a load at a speed of, okay, another hint here ialah load. Okay, your load is always at output side, yeah. So this is definitely P output at a speed. Okay, so your load is at output, rotor is also at your output, so this is your rotor speed or motor speed. Okay, again, you cannot calculate the synchronous speed, so usually the given speed is motor speed. And then the question gives you the total rotational loss 1 kilowatt. P rotational loss 1 kilowatt and the stator copper loss 200 watt. P SCR 200 watt. Alright. Determine. Number 1. The motor slip. Okay, determine the motor slip S NS minus NM over NS. You have your NM. You need to calculate your NS 120 F over P. You get 3000 RPM. Okay, so your S is 3000 minus 2950 over 3000 equals to 0.017. Okay, number 2. Number 2, the mechanical developed power. The mechanical developed power. So it's mechanical developed power atau developed power, also known as converted power. Okay, so write down the formula for converted power that you know first. Induced torque times omega m. What else? Another one is SP again. So can you use these two formulas to find P converted? Well, you don't know your induced torque. You also don't know your aggregate power. Can you calculate? You don't know your aggregate power. Can you calculate aggregate power? P aggregate equals to induced torque times omega s, or 3I2 phase squared R2 over S. So you don't have your induced torque, you don't have your I2 phase and your R2. So both formula we can't use. So we are left with no choice but to use the power flow diagram. So sketch your power flow diagram. P converted, P RCL, P core loss. This is PSCL, PSCL, PRCL, P mag loss is divided into 2, P rotational loss, and P friction and windage loss, and lastly P stray loss. So from the question gives you P rotational loss and PSCL 1K and 200. So this is 1 kilowatt, 200 watt. Okay, this core loss, mechanical loss and stray loss, if it's not given, we can assume as 0. 0, 0, 0. So our goal is to find your P converted, right? Well, at this point, can we find P converted by using plus minus? From the front, P in minus 200 minus PRCL equals to P converted, but we don't have PRCL, right? P air gap minus PRCL also equal to P converted, but we don't know your P air gap as well as your PRCL. How about from the back? P converted minus 1 kilowatt minus 0 equals to P out. Do we have P out? Yes, we have P out. At this condition, it's just that we need to convert this into watt first. Okay, so P out equals to per HP 13.4 HP. So if you want to convert it into watt, okay, you need to times with 746. Because, okay, actually the calculation is like this: 13.4 HP times, okay, 1 HP equals to 746 watt. So cancel out HP, so you get your P out in watt, that is around 10 kilowatt, yeah. So I'm following whatever the previous solution or answer stated in my solution. It's if it's not exactly the same, so it's around this value. Okay. Alright. So now you have your P out, so you can find your P converted. That is P converted equals to P converted minus P rotational loss minus 0 equal to P out. Therefore, P converted equals to P out plus P rotational loss, that is 10K plus 1K, that is 11 kilowatt. So done for your P converted or developed mechanical developed power. Okay, moving on. Number 3, the induced torque under this condition. So induced torque. So induced torque number 3. Number 3, induced torque. So actually, we have two formula for induced torque. Number 1 is Pi gap equals to induced torque times omega s. Number 2, P converted equals to induced torque as well, but times omega m. So it's up to you whether to use this or this formula. Okay, so for me, since from the previous question we already have the value for P converted, so why not we use the one that is related to converted power lah. So induced torque equals to P converted over omega m. So P converted settle, omega m equals to Nm times 2 pi over 60. So your Nm is 2950. So 2950 times 2 pi over 60 equals to '" Okay, again I don't have this answer, so just calculate yourself. Okay, so induced torque finally equals to P converted, that is 11k divided by your omega m. So your induced torque is actually equals to 35.62 Newton-meter. Hope we got the same answer, yeah. Okay, number 4 is the air gap power. PI gap. So PI gap, what's the formula for PI gap? Okay, number 1, 3I2 phase squared R2 over S. Number 2, induced torque times omega omega s. So we don't have I2 phase, we don't have R2, so cannot use this formula. Okay, but since we have induced torque and we can find omega s from NS, we can use this formula as well. Or another formula is, we know that P converted equals to S PI gap. So since we already have your P converted, we can also find PI gap using P converted over S. So there's two ways here. So it's up to you. Sorry, P converted is not equal to SPI gap, yeah? That is for PRCL. P converted equals to 1 minus S PI gap. Okay, so we can also find PI gap from here lah. That is PI gap also equal to P converted over 1 minus S. So PI gap, I think this is much easier compared to this, because to calculate using this, you need to calculate first your NS, which you already calculated here. So it's up to you. So in this solution, I'm going to use this formula, yeah. PI gap equals to P converted, that is 11k divided by your 1 minus S is, your S is 0.017. That is 11.19 kilowatt. So if you try to use this formula, you should get the same answer. Okay, moving on. Input power, and finally your efficiency. So for input power, P in. For induction motor, the formula for input power is 3 VT phase I1 phase cos theta. But we don't have your I1 phase, isn't it? So we can't use this formula. So we have no other choice but to use the power flow diagram. Okay. P in equals to P out plus P rotational plus P RCL plus P SCL, but we don't know your P RCL, right? So we can't use P out. So P in also equals to P converted. Yes, we do have P converted. Plus P RCL, we don't know your P RCL. Plus P SCL, we do have the value. So we cannot use P converted to find P in. And then finally, P in also equal to P add gap plus 0 plus 200. So you'll get your P in. So we can use that lah. P in equals to P add gap plus P SCL. That is 11.19K plus P SCL given from the question 200. Okay, so your P in is 11.39 kilowatt. So finally, you can find your efficiency. The final question is efficiency, right? Yeah, efficiency. So P out, your P out from the previous question is 10K. 10K over P in 11.39K times 100, you'll get 87.8%. Okay, then for question number 7. Okay, see you in the next video for question number 8. Thank you.